Hi everyone, here we are going to see about the Unit 4 continuation part. So let me see one by one. So that is the fixed point binary representation. So it means that the representation of the number with the integers and the fractional parts. So it should be represented in the name as that is dn minus 1, dn minus 2 etc. up to d naught, d minus 1, d minus 2 etc. up to d minus k square. So that is n is equal to summation I is equal to minus n to n minus 1 into di into r square. So it should be denoted as a QNM representation. So the binary point is implied and it will affect the accuracy of the number. So that is the dynamic range and precision. So purely the programmer's convention and has no relationship with their hardware. So this should be mentioned promptly that the fixed point binary representation is very important for the floating point method. For example, we can see here that is x is equal to 0, 1, 0, 0, 1, 0, 0, 0, 0, 1, 1, 0, 0, b. So now we have to maintain the fixed point number representation. So first is the 0.15. So that is x is equal to 2 to the power of minus 1, 2 to plus 2 to the power of minus 4, plus 2 to the power of minus 11, plus 2 to the power of minus 12. Next is the Q1.14, that is x is equal to 2 to the power of 0, plus 2 to the power of minus 3, plus 2 to the power of minus 10, plus 2 to the power of minus 11. Next is Q2.13, that is x is equal to 2 to the power of 1 plus 2 to the power of minus 2 plus 2 to the power of minus 9 plus 2 to the power of minus 10. So likewise we have to find out it for Q7.8 and Q12.3. So next is the effects of finite fixed point binary word length. So it means that the fixed point binary word length having the 4 types of effects. First thing will be the quantization errors. Second will be the truncation. Third will be the rounding, and fourth will be the data overflow. So first is the quantization errors. In quantization errors there are 2 types, that is the ADC and the coefficients. So here we have mentioned that the quantization methods that is having the in Dtsp, the numbers and the coefficients are stored in finite length registers. So the coefficients and the numbers are quantized by truncation or rounding. So when they are stored in the concept of the finite word length effect. Truncation means that is the truncation is the process of discarding all the bits less significant than the least significant bits, that is retained. Rounding means that is it is the process which is accomplished by choosing the rounded result closest to the original number and rounded. Next is the data overflow. So data overflow means that is the fixed point level has been overflowed and it should be stored in the binary word length. Next, ADC quantization error. So ADC will convert an analog signal x of t into digital signal x of n. So through sampling, the quantization and the encoding, assuming x of n is interpreted as a fractional number such that minus 1 less than or equal to x of n less than 1. So the dynamic range of the fractional number is 2. So since the quantizer will employ the b bits, so the number of a quantization level available is 2b. So the spacing between the two successive quantization levels is del, that is equal to 2 by 2 power b, that is equal to 2 to the power of 1 minus b. So the quantization error is modulus E of n is less than or equal to del by 2. Next is the coefficient quantization error. So it means that the effects on the FAR filters and the effects on IAR filters. So first thing will be the effects on FAR filters. It should be having the location of zeros that should be changes in a particular period. So next thing will be the frequency responses occurs in the FAR filters, that also should be changed. Next, effects on IAR filters. So there is the location of the poles and zeros that should be changed according to the FAR filters, and it also could move poles outside the unit circle, which will be lead to the unstable implementation. So the quantization error will be having the effects in the coefficient level. So it should be recognized by both the FIR as well as the IAR filters. Next is the overflow error. So it means that the signals and the coefficients which are normalized in the range of -1 to +1 for fixed point arithmetic. So the sum of the two b-bit numbers that should be may fall outside the range of -1 to +1. So it should be distort the signals. It also handles the overflow level of the single method. So there should be a saturation arithmetic. So there is a clips the signal which should be better than a overflow. So it should only be used to guarantee no overflow, but should not be the only solution for this overflow error. So it also having the scaling of the signals and the coefficients that maintain the coefficient level as a normalized part of the ranges from -1 to +1 level.